Hello, this is Eddie Barragon. So this is the final video presentation for the class of Principles of Biochemistry 530 for Grand Canyon University. I will be covering and explaining and going over the topic of glycolysis in comparison and contrast to the process of gluconeogenesis. As with the last presentation that I did for this class, this is going to be more of a template for a instructional presentation. It's not necessarily just going over the information itself. That is obviously a very important aspect of it, but to use as an example for how I would go about presenting this information to a classroom of upper level university students or potentially even graduate students. So with that in mind, yes, I hope you enjoy my final presentation for Chemistry 530 and Grand Canyon University as a whole. So this, without further ado, this is Glycolysis and Gluconeogenesis by Eddie Barragon, as I would go about teaching a classroom. Thank you. So first things first, for the introductory phase of this, I just want to go ahead and introduce the two processes, kind of compare and contrast a little bit. So glycolysis and gluconeogenesis are incredibly important and critical physiological processes that occur in the body. This presentation is going to focus on the comparing and contrasting between the two. So basically, glycolysis breaks down glucose and extracts energy from that process in the decomposition, well, not the breaking down and essentially releasing energy from glucose in the body. It's typically through the breaking down of tissue and tissue that is storing said glucose as energy or fat, or as gluconeogenesis is exactly the opposite. So a little bit more detail into the process of glycolysis. Glycolysis is the process in which glucose is converted to pyruvate and or lactate as the end product, or the almost, I don't want to say this entirely because it's not entirely accurate, but waste products of the process of glycolysis. It is a metabolic pathway that occurs in the majority of living organisms, specifically in the liquid part of the cell. So glycolysis, for that particular reason, a lot of researchers believe that it was more or less something that occurred once within the process in the course of the evolution of energy retrieval and glycolysis breakdown of the liquid part of the cell for glucose, allowing us to be able to chemically use that, and in the process, other further metabolic processes down the line, cellular respiration, photosynthesis, so to speak, as an example. So yeah, that's essentially what I would want the main takeaway for my students to be, is understanding what glycolysis is, what the waste products are, what the purpose of the metabolic pathway is, a little bit of the background history and information on glycolysis, and a little bit of the, how it relates to not only humans, but also all life on Earth. It's a very important process to get down, because as I mentioned before, it is the building base for a lot of other biochemical reactions that they need to understand in further detail down the road in their education and academic careers. So gluconeogenesis is a little bit more of a complex of a process and a topic, in my opinion. It is the process of how the body is able to produce sugar through the breakdown of solid lipids or adipose tissue. In essence, or fundamentally I should say, it is the inverse of glycolysis, and it is the body's way of extracting energy from non-carbohydrate energy sources. What does that mean? It means that's basically the body's process of burning fat for energy during intense bouts of exercise or long-term bouts of consistent physical performance. It's something that a lot of people misinterpret, I would say, because it's not necessarily the secret to weight loss, as I have heard or read it be mentioned in a few times. It's more of just the action and the process, but it is obviously linked to how adipose or fat tissue does get burned, and how our body breaks down and uses it over time. So it is an important and relevant process to the process of, you could say weight loss, but fundamentally as a biochemical metabolic pathway, it serves a much greater purpose than that in terms of maintaining the body's energy stores, using it efficiently and functionally, and basically the overall maintenance of our body's homeostatic existence, I guess you would say. So yeah, it fundamentally is the inverse of glycolysis, but it is no less important and is just as crucial, especially with, like I said, higher level vertebrate organisms like us. Breaks down solid lipids or adipose tissue, so leading to fat evolving as an efficient energy storage method. There's a lot of organisms that take advantage of that, through hibernation, stuff like that. So there's different kinds of adipose tissues, different ways gluconeogenesis can influence those. So that's what I wanted to go over and kind of elaborate on gluconeogenesis, as a lot of people misunderstand it as just the process of burning fat, which it is, but it's a lot more than that as well. So thank you. So for the key principles, the main takeaways that I would want my students that I teach to have would be to understand the main differences between the two. Comparing and contrasting glycolysis and gluconeogenesis, the breaking down of glucose through glycolysis in the liquid portions of the cell, and how we get energy from that, whereas gluconeogenesis would be the breaking down of actual physical solid lipid tissue, and with different functions and different purposes between the two. Glycolysis being more of an immediate energy source with waste products, pyruvate and lactate, waste products, so to speak. With gluconeogenesis being more of a longer term, more efficient energy storage usage method. Again, highly related and closely intimate with each other, but not necessarily functionally identical. So yeah, basically, for them to be able to understand the main metabolic pathways and the purposes of both. It is important, as I mentioned before, because it does lay down the building blocks of other physiological processes that they would have to understand in the future. For example, photosynthesis is the obvious one. The way the sugar is able to be created through the process of the sun interacting with water in a plant cell, and the chlorophyll allowing it to be transformed, the thermal energy of the sun itself, into glucose proper. Another related process is cellular respiration, the production of ATP through mitochondria, energy release, and ATP creation, and inherent water and NADH and all those other waste products, or byproducts, I should say. Byproducts is the most efficient term to describe what is created in the aftermath of those processes. So getting students to understand the basics of each principal metabolic pathway would be my main goal, and getting them to understand down the line what it could mean and how it influences those processes would be, the ultimate main goal, to further them along as they continue taking more and more material and difficult classes. Something I would like to touch upon for this presentation, and also something that I would want to carry on over when I teach this to students down the line in my classroom, is showing and telling students the innovative and often, revolutionary new methods and research and breakthroughs that are being made in the development of whatever they're learning. So for glycolysis and gluconeogenesis, there's a massive amount of ongoing research in the field of studying these two metabolic pathways, and there are constantly new developments and more discoveries and further applications down the line that are being discovered with these two. There are new ways of analyzing the process involved and predicting how the body is able to deal with the metabolic pathways of glycolysis and gluconeogenesis. What that means is, there's new research in terms of how these are able to operate within an individual, what deficiencies might be there that are influencing the body down the line, whether it's an inability to process and extract nutrients. That's a little bit more extreme, but it's there. Scientists and researchers are constantly looking for ways to improve their understanding and their ability to analyze and use the information to predict the health of an individual, or the potential complications an individual may be able to face, and ascribing them better treatment and medication for whatever affliction ails them. So again, this is something that I would want to introduce to my class, and I would want to talk to them about, there's always something new going on with whatever you're learning. And a lot of people don't realize that. A lot of people think that the material is stale, that it's not changing, and it's not ever growing. And quite frankly, that's rarely ever the case. No matter what you're learning, there's always something new going on. There's always someone taking a fresh look at it and bringing a new perspective to it, and discovering something that, maybe hasn't been seen before, or hasn't been studied in a particular way before. So that's important to learn as well. So a little bit slightly just an addendum in addition to the overall topic of the presentation. I'd like to go over some of the teaching tools that I would implement in teaching this information to my students. I would incorporate a variety of teaching tools. For example, these would come in the forms of, let's say, presentations like I'm doing now, where it's recorded or live if it's a physical classroom. Most likely recorded if it was an online class. I really, as much as I love the online format of a class, I think having recorded lectures would be a great benefit, especially for some of the classes I have had. Videos, YouTube videos, of course, that's the standard by now for a lot of classrooms and for a lot of additional teaching instructional videos, or even if it's videos that are recorded by the professor themselves that are relevant to the class more specifically, those could also be incorporated into the classroom. group assignments, not necessarily group projects, but group assignments like, discussion forums and discussion posts like GCU has. I really like the forum. So questions, elaboration. This is where I would end the presentation and give students a chance to ask their own questions. I think it gives students not only a chance to engage, which is important because participation is a big way that some students learn, whether it's physically or online, doesn't matter as long as they get the chance to engage and participate with their fellow students or peers or professors. But also, it gives students a better opportunity to get a more essential or proper understanding of the material itself. That's critically important, of course. Being able to ask questions on a particular aspect of the subject that you're not 100% familiar or really comfortable with, that's an important step for any student in their learning journey, right? Learning how to raise their hand or step up and ask questions. Something that I've also learned is that a lot of times a student might not ask a question because they might be nervous or shy or anxious or whatever. So when another student asks a question, whether it's the same one they were going to ask or a related topic or a related issue, that brings the information to the forefront. That gives them a chance to learn from that student's question and what the instructor was able to give to them. So I'm a firm believer that there's no such thing as a stupid question, that there's no such thing as too many questions. I learn by correspondence. So what does that mean? I learn best by examples. I learn best by visually. Like a lot of people like to say I'm a visual learner, which is great, and I think that's true for a lot of students, and I am as well to some extent. I am a learner by correspondence. I need to see it, I need to have it explained, and I need the information that goes along with it given to me as well so that I can analyze it and digest it on my own, and I can come back and ask whatever questions are related to the material that, might not be obvious at first. I'm a deeper learner. It's not that I don't understand information necessarily quickly or immediately. I think that's a misunderstanding. First of all, there's a lot of students who maybe can see something or read something and get a very passing, surface level understanding of the material, but what do they really know deep down on a multi-layer deep, complex, detail-oriented aspect of the material? A lot of them don't really know fundamentally what the material is or what they've learned, quote unquote. So even students who are confident in themselves need to be able to ask questions. They need to be questioned. They need to have the answers given to them to questions that maybe they never would have thought of asking before. So again, I'm a firm believer of questions. I'm a firm believer of giving students more information than they think they need, because a lot of times they do need it. So just like with, in the subject we're discussing, glycolysis and gluconeogenesis, they're relatively straightforward concepts in my opinion, but the details are many. The aspects that they influence are many. It's intercomplex and interconnected and interdependent, and that's where a lot of students really don't realize that. They might think that they're learning about glycolysis and gluconeogenesis, but they're not understanding that those are small pieces of a much larger puzzle. Getting them to connect the dots and make logical connections, that's important too. And the more students understand that, by asking the more questions that they can, the better. So in conclusion, just to tie things off and end the presentation and lay out the final details of the subject matter and the additional teaching steps that I would incorporate, I would want students to know glycolysis and gluconeogenesis are directly tied to one another. They are basically the exact inverted processes of each other. That's the main key takeaway. Obviously, there's a million other details that they would have to learn and incorporate, but that's more of a longer term journey that I would help them and facilitate their growth in. It's not the most intuitive processes to learn or to teach students, at least initially, at least in my opinion, from having studied it myself. But they are very important. An individual has to have a good understanding of these processes, as they are a building base for more complicated processes down the line. So yeah, that's kind of been my format for how I would go about teaching this material, how I would go about instructing this material, what I would want my students to learn, what I would want my students to take away from it, and how I would want my students to approach me if they wanted to learn more, or if they wanted more details, or if they had questions that they wouldn't be nervous to ask and that they thought would be, a question not worth asking. I want them to know that that's always the case. There's no wrong way to go about thinking about things, right? In science, we don't teach our students what to think. We don't. That's on them. We can give them the tools and the resources and the data and the information, because that's not subjective, that's objective, right? The objective data is the data. How they go about analyzing that and interpreting that, that's up to them. That's up to what tools and what methodology they want to go about testing it or analyzing it or researching it more so. Granted, they have to understand that that's open to interpretation and that's subject to scrutiny, and like all things in science, it's going to be tested or challenged, refuted, rejected, and that's normal. That's a good thing, because that means we're all learning more, right? We're learning what's not true, and that's often just as important, if not more important, than learning what's true. So that's how I would approach my teaching style, my teaching presentation. Getting students to understand the basics, as is the case of glycolysis and gluconeogenesis, that opens the door to a world of greater understanding, and that's something that I want to incorporate in my career going down the line as an educator. It's not perfect either. I will be subject to learning and adapting, and I think a lot of educators get stuck in how they present material, or how they teach material, and don't adapt and change and incorporate that with their students more. That's something I want to do, because I think once an educator stops learning, they no longer are effective educators as well. That's my opinion, and I'll stand by that. But yeah, in conclusion, that's the processes involved. That's the perspective that I have, and that's how I would go about teaching this on my own. So thank you for joining me on my final presentation for biochemistry for this class. And also for my final presentation and assignment overall for Grand Canyon University. Thank you. It's been a great journey, a great ride, and I'll thank you again, Grand Canyon University, and this will be important to me and crucial to me as I continue my academic journey and professional journey in my career. Thank you. Bye.